Well, now that you've been introduced to the idea of a limit and its algebraic substitution, just dropping a number in, and then on a graph approaching from the left side and the right side and finding out if those two arrows meet each other or not, now you're ready to talk about limits a little bit more in depth in terms of what are their properties, what do you do when substitution fails, when you drop a number in and whoops, you get something that is illegal, and something called an indeterminate form of a limit. And then some of the real math, not the fake math, but real math we can do algebraically to solve limits. So that's what we're going to talk about in 1.1b. Some properties of limits. Some of these are pretty basic. The sum rule means you can add two limits together. The difference rule means you can subtract two limits from each other. So those are pretty fundamental, pretty basic. So what's legal to do with limits? So you got to know, real math, fake math. Okay, real math, you can add and subtract limits. You can multiply. That's called the product rule. So you can multiply two limits together. Constant. My AP students have trouble with this one. Okay, K is a constant. If it is, then it can get pulled out in front of the limit. Now, sometimes my AP students try and do fake things like pull a variable out in front of the limits, but a variable is not a constant. This is only the constant rule that can get pulled out in front. And then the quotient rule. You can divide limits as long as what you're dividing is not 0, because remember, you can never have a denominator be 0 in math. So the legal math is to divide limits that aren't equal to 0, but if you do, then you're going to need to know what to do about that. So here's some samples of some quick questions you might do with the properties of limits. So let's suppose that the f function, as you approach a, has a limit value of 4, and the g function, as you approach a, has a limit value of -1. So the next question is, find the limit of f minus g. And that's a legal thing to do, that you are allowed to subtract. And so the answer would be 4 for f, minus -1 for g, and so we get 5. The next question is the limit of 2 of g x quantity squared. So the 2 is a constant. It can get pulled out front. And then g of x squared means g of x, whoops, I need my limit, 2 pulled out in front. And then g of x times g of x. And the constant pulling out front is legal, and multiplication is legal. And so since those two things are both legal, I can say 2 times -1 times -1, and so the answer is 2. And then finally, 3 minus g of x over f of x. So subtraction is legal, so we can have 3 minus -1 divided by, and division is legal as long as you're not dividing by 0. And we're not, we're dividing by 4. So we get 4 over 4, and the answer is 1. So those are some ways you can work with the properties of limits, doing what's legal to do with limits. Now let's look at what happens maybe when the substitution fails. So here's a limit of a square root, and we're going to take the number 5 and we're going to plug in. So we'll get the square root of 3 minus parentheses where we substituted 5. That's the square root of -2. And that is the square root of a negative number. And we're not dealing with imaginaries. There are no i's in limits. And so this does not exist because we can't take the square root of a negative number. For the second one, we'll plug in, x is 2. And so we'll get the natural log of parentheses 2 where I substituted minus 4. That's the natural log parentheses of -2. Again, you can't take just like you can't take the square root of a negative number, you can't take the natural log of a negative number either. And so that would also be does not exist. So some of the things you cannot do Okay, you cannot divide by 0. You cannot square root a negative number, and you can't take the natural log of something that's not positive. Now, what about this situation? We're going to put an equal sign, and we're going to substitute in 0 twice. I'm going to get parentheses 0 plus 3 quantities squared minus 9 over 0. That's 3 squared minus 9 over 0. That's 9 minus 9 over 0, which is 0 over 0. This is not a D&E situation. So I just need you to hear me. If you say D&E, that is fake math. D&E is when you're dividing by 0 for anything except when you also have 0 in the numerator. This is a special form of an answer. So let's move on to the next slide. You have always learned that anything divided by itself is 1. 4 divided by 4 is 1, 6 divided by 6 is 1, pi divided by pi is 1. But what about 0 divided by 0? Is it 1? Because anything divided by itself is 1. Is it D&E? Does not exist, because when you divide by 0, it does not exist. Well, it's not 1. It's not D&E. Those are both fake math things. This is a new kind of number, which I don't think you've seen in any math class before. This is called an indeterminate form. Look how to spell it. Okay, indeterminate. Terminate. Indeterminate form. 0 over 0 is a special number in math called an indeterminate form. It's not 1, it's not D&E, it's simply an indeterminate form. When that happens, and it's going to happen a lot in your homework, there's special math that you have to do to an indeterminate form. So here, when you get 0 over 0, you should try FOIL. You should try factoring. You should try reducing. Or you should try common denominators. These are the 4 strategies that are legal and required when you get an indeterminate form. This is only for the indeterminate form 0 over 0. There are going to be other indeterminate forms. This particular indeterminate form is the only one that you're going to encounter today, and these are the 4 strategies that you would do when that happens. So let's go back to this problem we were looking at. Okay, we showed that this was 0 over 0. So I'm going to start the problem over, and I put an equal sign to show that I'm doing something legal. I write limit, and I put parentheses, and I'm going to show the algebra that I'm going to do next. My first algebra that I'm going to do is FOIL of x plus 3 quantities squared. So I'm going to have x plus 3 FOILed with x plus 3. And I still have minus 9, and I still have over x. As long as you are doing legal algebra, you need to write limit in front and parentheses around it. I will mark off if you don't have equal signs from one step to the next, if you don't have the limit notation from one step to the next, and if you don't have parentheses from one step to the next. These are, you are now in calculus, you're expected to write things the correct way, and these are part of the correct notations, okay? Having an equal sign in front of every algebraic step you do, having a limit in front of every algebraic step you do, having parentheses around every algebraic step you do. That's part of the requirements. Just as if you were writing an essay in English where you have parentheses, have periods at the end of sentences in the right place, using semicolons or colons in the right place. You just need to be a good math writer. So I'm going to do the FOIL. So I'm going to have x squared plus 3x plus 3x plus 9. I still have minus 9. I still have over x. equals. I'm still doing algebra, so I still need the limit and I still need a parentheses. Now my algebra says that the 9 and the negative 9 cancel out. So I'm left with x squared plus 6x over x. I'm still doing algebra, so I still have an equal sign, and I still have the limit, and I still have parentheses. So I have FOILed out, I've combined like terms. Now I'm going to do common denominators. X squared over x, 6x over x. So now I have a common denominator. Again, that is legal. Only when you're adding and subtracting. This is an addition problem, so I have a common denominator. I'm going to do some more legal algebra. Equals, limit, x approaches 0, parentheses, always required as long as you're doing algebra. Now I'm going to reduce. X squared over x reduces to x, plus 6x over x reduces to 6. There is no more algebra for me to do. I have FOILed, I have simplified, I've done common denominators, I've done reducing. Now I can finally plug 0 in, and I get 0 plus 6, and the answer to this problem is 6. So remember, at the very beginning, we got indeterminate form. Don't stop there. The answer is not 1, the answer is not D and E. It requires some more steps, and then you come up with the actual answer, which is 6. So let's try that again. Here's another limit. The first thing I try is always substitution. So I'm going to put the number 2 in for all my x positions. That's not algebra, that's just math. So I use parentheses, not limit. So 2 parentheses 2 minus 4 over 2 parentheses cubed minus 2 parentheses 2 squared. 4 minus 4 over 8 minus 8. 0 over 0. My indeterminate form. So I start over and I go back to algebra, which means I need to go back to writing limit equals limit parentheses. This problem needs some factoring. In the numerator, I'll take out 2, leaving me with x minus 2. In the denominator, I'm going to erase some of these so it's a little easier for me to see. I'm going to take out what's in common. I'm doing GCF factoring, and I'm going to take out x squared, leaving me with x minus 2, parentheses. So I just factored out a GCF. Now I notice I can reduce. This is still algebra, so I still do an equal sign. I still do a limit. I still have x approaching 2. I still have parentheses. And what I'm left with is 2 over x squared. There's no more algebra for me to do. I'm going to do a substitution. So I don't have to write limit or parentheses anymore. So I'll have 2 over 2 squared, or 2 over 4. And so the answer to this problem is 1/2. So notice, even though I got indeterminate the first time, I didn't stop there. You do the legal algebra and you come up with the actual limit, which is 1/2. So this tells you that this function, when x is approaching 2, the y value is approaching 1/2. It won't necessarily get there, but it will get really, really close to 1/2. It's approaching, not reaching, but approaching. Let's try another one. I'm going to try substitution first. My 0 is going to go in for my x values. That will give me, and I don't need limit when I'm doing substitution, 0 minus 3 plus 1/3 over 2 times 0. That's negative 1/3 plus positive 1/3 over 0, 0 over 0. So another indeterminate form. So I start over with an equal sign, a limit approaching 0 in parentheses. It's like announcing to the world, I'm ready to do algebra. And my algebra this time is a common denominator between the terms of the numerator here that need a common denominator. So 1 over x minus 3, it needs the denominator 3 over 3. The 1 over 3 needs the denominator x minus 3 over x minus 3. All of this is over the original denominator, 2x. So I'm getting a common denominator to help me out. I'm still doing algebra, so I'll put an equal sign followed by parentheses. So what do I have? I have 3 over the common denominator now, 3x minus 9, plus I have a numerator that's x minus 3 over the common denominator, 3x minus 9. All of that is over the original denominator, 2x. Common denominators are only appropriate when you have addition or subtraction. So this is an addition problem. It started out as an addition problem. That's why I use common denominators. Fake math would be to do common denominators when you have multiplication. This is not multiplication, this is addition, so this is legal. Equals, limit as x approaches 0, parentheses. Now I'm going to group my numerators together. So my numerator is 3 plus x minus 3. When I group those numerators together, the lead 3 cancels out the negative 3, and I'm left with x over the denominator 3x minus 9 over the original denominator 2x. Now at this point it's awkward to have what looks like two denominators. I've got 3x minus 9 and I have 2x. So I want to multiply by the reciprocal instead. So I'm going to erase the divided by 2x, and I'm going to change it to a multiply by the reciprocal 1 over 2x. Okay, legal algebra. Now I reduce because I have multiplication now. See how it's different? It used to be a plus, but now it's multiplication. As a multiplication, I can reduce x here with x in the denominator. And that was a legal algebra move to do as well. So equals the limit approaching 0, parentheses. Just keep doing that as long as you're doing algebra. So my numerator is now 1. My denominator is 3x minus 9. And I also have the 2 left. There's no more reducing, no more FOIL, no more factor, no more common denominator for me to get. So now I can do substitution. And I'm going to put 0 in. Once you do substitution, you don't need limit or parentheses anymore. So 1 over 3 times 0 minus 9 times 2. That's 1 over negative 9 times 2, or negative 1 over 18. The negative shouldn't stay in the denominator. The negative can go right out in front of your fraction to show that the whole fraction is negative. So the answer is negative 1/18. This is our last example. So I'm going to take the number 2 and I'm going to substitute. When I substitute, I don't need to write limits. So I'll have 2 cubed minus 8 over 2 minus 2. That's 8 minus 8 over 2 minus 2, which is the indeterminate form, 0 over 0. Always try substitution first. You might not get 0 over 0, but most of the problems in your homework you are going to get 0 over 0. So we're going to start over. the limit as x approaches 2, parentheses, I need to do some algebra. Now this is a factoring style that you might not remember or be as familiar with. So I'm going to go to my last slide where I have a blank slide so that I can remind you how to do this. There's a factoring called x squared minus a squared. This is the difference of squares. And you might remember that that factors into x minus a, x plus a. Okay, that is called the difference of squares. This question doesn't have squares in it, it has cubes. And there is also a factoring called the difference of cubes. And the difference of cubes also starts with x minus a. But its second factor is different. It factors into x squared, it's all positive, plus ax plus a squared. That format is called the difference of cubes. So I'm going to need that pattern for this particular question. Looking back, I noticed that 8 is 2 cubed. So this is x cubed minus 2 cubed. Over x minus 2. Now fake math, somebody might start going, oh, reduce, 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 reduce. Okay, that's total fake math. You can't reduce without factoring. So I'm going to take all of my reducings away. Right, so it looked like maybe reduce and reduce like that, but you can't do that. So we have to make sure we are doing it legally. So the legal way would be to use the difference of cubes. So the difference of cubes says to factor that into x minus 2 plane. And then everything else is positive. X squared plus 2x plus 2 squared, which is 4, all over x minus 2. Now I can reduce. Because I've factored, I can take my x minus 2 as a quantity in parentheses and reduce it with another x minus 2. So again, I'm still doing algebra. So I put equals, limit, parentheses. What I have left is x squared plus 2x plus 4. Now I can go back to substituting, and I'll take my 2 and I'll substitute. So now I don't need limit or parentheses anymore. 2 squared plus 2 parentheses 2 plus 4. That's 4 plus 4 plus 4. And so the answer is 12. So what this means is that when x approaches 2, this function y value is approaching 12. It won't get there, but it will approach and be very, very close. All right, so I hope that all made sense to you and that you're able to work through the legal algebra of factoring or foiling or common denominators or reducing. So I hope I highlighted the places where you might be tempted to make a mistake, where it would be illegal to reduce or illegal to do a common denominator. So just to summarize that, when you're adding or subtracting, common denominators are okay. That's what you want, but no reducing. And then when you are multiplying, reducing is okay, but not common denominators. So it's the opposite. Even though we're tempted to maybe treat them the same. Division is the same as multiplication. The rules are the same because division is the same as multiplying by the reciprocal. So any rules that follow for multiplication also follow for division as well. You just turn your division into a multiplication by the reciprocal. Okay, so we'll go over this together Wednesday morning during our Zoom. I hope this is enough to help you be successful in your homework. All right, good luck, and I'll see you on Wednesday.